Let's talk about an easier way of dealing with absolute value inequalities. Here we have an example of an absolute value inequality. And this one is the absolute value of x is less than 3. Now you may have learned at one point that you can turn that when you have a less than symbol in an absolute value inequality of this type, you can turn it into a three-sided inequality. Your three-sided inequality might look something like this. You have -3 on the left, you have x in the middle, and you have 3 on the right. And then you can write your inequality symbols in between. All right, now this particular situation is called a conjunction. And it's taking me a while to write this, but again, this is called a conjunction. And what made it a conjunction was that we had the less than symbol. So if we have the less than symbol or we have the less than or equal to symbol, that makes it a conjunction. And so when we graph this, put this on a number line. Let's try that again. We put this on a number line. We have two key points. And by the way, when you're drawing number lines, don't worry too much about marking them and counting the number of spaces in between marks. In this inequality, there are really only two important points, and they are -3 and +3. Okay, and then let's consider what's happening at those points. Now, since this was a less than symbol, we know that at -3, x is not going to be equal to that. So let's draw an open circle there. Likewise, at x is equal to +3, that's not part of this inequality. It's not included because that's a less than symbol, which excludes the value of 3. So what happens here is that everything that's in between, and let me try drawing that again. Everything that's in between those two circles, meaning all the numbers that exist on the number line between -3 and +3, will solve this inequality. And the only parts that will be excluded are -3 and everything to the left, and +3 and everything to the right. So in this situation, again, we had a conjunction, and that conjunction could be written as a three-sided inequality, which we then could solve by looking at the number line. Now, here's the new thing that I want to introduce to you. All right, the idea that, again, here we have an absolute value inequality, but this time the inequality symbol is a greater than symbol. And this is a special situation. This is called a disjunction. Once again, I just want to reiterate, this is called a disjunction. And a disjunction exists wherever we have inequalities in which we have a greater than or a greater than or equal to symbol. Okay, either one of those inequalities will give us a disjunction. Now, the thing here is, though, and this is what's new, that you may not have thought about before, but when you have a disjunction, you can also write it as a three-sided inequality. So we can write -3, and let me try that again, -3, and put x in the middle, and put +3 on the right. Okay, but in this situation, since this is a disjunction, I want to be very careful not to put inequality symbols in between the x in the middle and the numbers on either side. I'm not going to do that in this case. If it's a disjunction, do not write inequality symbols between the x or the variable expression and the numbers. Okay, however, we are going to go on and draw the solution on the number line for this disjunction. So our two critical numbers again were -3 on the left and +3 on the right. And just like we did in the last case, we're going to draw open circles at -3 and +3 because of the inequality that we were dealing with in the first place. Notice that there was no equal sign with it, so it is a greater than symbol. Not greater than or equal to, but greater than. Consequently, those 2 points, those 2 values are not included in the solution. Now, here's the difference when you're dealing with a disjunction. With a disjunction, when we draw our solution, it's going to include all the numbers that are not in between the 2 critical values. So in other words, the solution is going to include everything to the right of +3 and everything to the left of -3. So that graph represents our solution. So in this particular disjunction, the solution of that disjunction is all of the values of x that are greater than 3 or less than -3. So now we can write those. We can write those 2 inequalities. We can say that x is greater than 3 or x is less than -3. And that's the solution to our absolute value inequality, which happened to be a disjunction. So the order in which I'm suggesting that you do these problems is when you recognize that you have a disjunction because you're dealing with either a greater than symbol or a greater than or equal to symbol, is first of all set up your 3-sided situation. Reduce that 3-sided situation so that you get x. Plot the critical values that result on the number line. Show that it's a disjunction. If it's a greater than symbol, you have open circles like the ones that I showed here. If it's a greater than or equal to symbol, then you would shade in those circles and have closed circles. And then based on what you see in your number line drawing, write down the solutions that are for the absolute value inequality. And I think that doing this will make it much simpler. Now, additional videos will show some more examples of this.